Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 18 on our 2019 Fermat paper. So hopefully you've given it a bit of a try. Just a quick reminder, if you want to try any of these contests before watching the video, you can get a copy of the contest by clicking the first link down there in the description. Okay, so with that said, let's take a look at question number 18. How many 7-digit positive integers are made up of the digits 0 and 1 only, and are divisible by 6. Okay. So only zeros and ones. So the first thing I'm thinking is, well, you can't start with a 0, otherwise you're not really a 7-digit number. Leading zeros don't count. But then my next thought is, well, how do you tell if something's divisible by 6? How do you tell if something is divisible by 6? Well, 6 is 2 times 3. Those are both prime numbers. Okay, and then, so it's 2 times 3. So if I can show that a number is divisible by 2 and divisible by 3, it will have to be divisible by 6. Okay, it's a nice little result. So, okay, how do you tell if something's divisible by 2? Well, it's got to be an even number, so it's got to end in 0, 2, 4, 6, or 8. Well, I'm not allowed to use 2, 4, 6, or 8, only ones and zeros. So automatically, if I'm sort of imagining a 7-digit number, 1, 2, 3, 4, 5, 6, 7, it's got to end in a 0, otherwise it's not even, it's not divisible by 2, and so can't be divisible by 6. Great. Okay, well, how do you tell if a number is... Oh, by the way, you also have to have a 1 at the start, as I was saying. You can't start with a 0. Doesn't count. Now, how do you tell if something's divisible by 3? Well, there's a way to tell just looking at the digits. It's called a divisibility rule. It's, sort of like looking at the last digit tells you if you're divisible by 2, but the rule for 3 is a bit more complicated. Okay? So if I've got a number and it's divisible by 3, it's divisible by 3 only if the sum of the digits is divisible by 3. Okay? Now, we know we've got at least a 1. We could have at most 5 other ones. So you could be looking at 6 ones. And so 6 ones plus a 0 would add up to 6. Can we think of other sums that we could have? Well, 9 would be nice, but you're not going to have enough 9. You're not going to have enough ones to make a 9. 3 is certainly a multiple of 3. So I could use 3 ones and the rest of them be zeros. Could I get a sum of 0? No, you've already got a 1, so you're definitely committed to having a digital sum, as it tends to be called, of at least 1. So let's look at some cases. So the sum of the digits is 6. Well, in order to get that, you need 6 ones. Right, but you're only allowed 7 digits. We know the last one has to be 0. So there's just this one possibility, this one case. Okay? But if the sum of the digits is 3, well, then I get only 3 ones. I know the first digit has to be a 1, the last digit has to be a 0. And then I've got 5 digits in between. 2 of them have to be 1s, because I'm only allowed 3 1s, and one of them's already spoken for. So I have 2 1s, and the rest are zeros. And so we could think of ways to put them in. You could try and do 1 1 and then 0 0 0. As long as you're methodical, you're not going to sort of lose track of your way. Now, some of you out there might say, "Oh, well, I've got 5 things, and I need to choose 2 of them to be 1s. This is 5 choose 2." And if you know combinatorics, you know binomial notation, that is fantastic. You'll probably know the answer is 10. And so then 1 plus 10, the answer is going to be 11. But if not, we probably are going to need to write out these cases. And so we want to do it in a very organized fashion. That way we don't miss something. So I'm going to keep the 1 on to the left and just move the second one over incrementally until it hits the end. And then I'll move this first one over by 1 and do the same sort of thing. Okay? And I'll write out my cases, and hopefully I won't lose track of anything, and we will get 10 in the end. So there's 4 ways to do it where the second digit is a 1. Okay? Put these placeholders here again. Now, what if the first digit is a 0? Well, first digit after the actual first. So, the second digit is a 0. Well, let's put the 1 here. And then we'll put the other one next to it. So So we'll keep this one here as much as we can and move the other one over. And fill everything else in with zeros. So there's 3 more. Now this one has hit the end, so we'll move this one over 1. Put this one back beside it. Fill everything in with zeros. Move the second one over. It's hit the end, so there we're done. And we get our last cases. So this is 10 cases overall. These 6 plus the 4 we had over here. And then this 1 case here, so 10 plus 1, 11 possible 7-digit numbers. So 11 is going to be our answer. You can see 11 is there. 10 is there. You don't want to fall into this trap. 10 is there for the people who forgot sort of this case over here. Okay? Who left that one out. But we didn't. Because we're fancy, we're smart, we're attractive. So we get our answer of B, and that's going to be our answer to question number 18. All right. There we go. Up next is going to be question number 19. So thank you guys so much for joining me, and until the next video, take care.